ASE Study Questions 1-2. This is going to be questions 1 through 5. All right, first question. The hydraulically controlled automatic transmission is not shifting correctly. Which service procedure should the technician perform first? Well, this question has the possibility of performing a pressure test, adjusting the bands, checking the transmission fluid, or checking for proper engine vacuum. They try to throw you off in this question by saying a hydraulically controlled automatic transmission is not shifting correctly. It really doesn't matter which type of transmission you're working on. You're almost always going to start with checking the fluid. Now, that being said, you will want to start by verifying the concern. Because if you go drive the vehicle, and let's say that vehicle has a characteristic that is not abnormal, but it's actually very normal for that vehicle, you can then tell the customer that this isn't something that can be fixed. Because remember, the first time you put a tool on that vehicle, it's an admission that there is something wrong with it. So you want to make sure you verify the concern. But this question here, the best answer for it was to, check the transmission fluid. So, let's say you verify the concern, you come back from that short test drive that it requires, and you check the fluid. Now, it's no harm if you check it before you drive it, because maybe the fluid is too low and you can't drive it. So make sure you check the fluid around the time of test drive, before or after. That'll help you to figure out, is there something major wrong with this transmission, or it could be something simple. Now, by checking the fluid, you're going to look to see what's the condition of the fluid, what's the level, obviously. Are there any conditions in the fluid that would indicate something is wrong, either from previous service or something is worn out or broken or damaged inside the transmission. So make sure you start with the fluid. Now, here in this picture, you see somebody's checking the fluid in this transmission. It's got the two levels, and I don't remember if we spoke about this, but there are two levels on many dipsticks. So you see there's actually two notches, one notch here and then a notch there. That's the cold level. So if you were to first, say, service the transmission, you put in the fluid and you're starting to fill it up, but it's still cold, you're going to fill it up in between those two notches. As it gets up to temperature, up to operating temperature, then you're going to want that fluid to be within the cross-hatching on the stick. Now, this is one style. Another style of transmission dipstick, instead of having notches, it'll actually have holes drilled in the middle here, and then in the middle here there'll be two holes, and that'll be your cold indicator. And that'll tell you where to fill it up when it's cold. Over here on the right, these are some pictures, and we've talked about these before, but if you pull that dipstick out and the transmission fluid is pink, and it's going to be a thick, tacky pink, not tacky color, but it's going to be tacky texture. There's water in that transmission fluid. And if it's a four-wheel drive truck, then it's probably been off-road. If not, it could be getting coolant from the radiator. It could have been maybe submerged due to high water from recent rains or whatever. If you look at the next one down, if it's got the normal transmission fluid smell and color, it's probably just been serviced, and maybe what you're looking for isn't a clutch or band issue. It could be, electronic or some other concern. It could even be engine related, engine performance related, because engine performance and transmission operation are very closely related. The next one down, the maroon, that's when it starts to turn brown, starts to head towards the brown color. Now, it doesn't necessarily mean that fluid is bad, or even that it's old, because the colorant in transmission fluid will tend to change state first. So fluid might be old, but it could actually still be good. Now we get down, once it starts to get more to the brown side, that's when you're going to start to give it a whiff. And that transmission fluid will, if it's got something wrong inside it, clutches slipping or band slipping, it'll start to have an acrid smell. Smell good transmission fluid in a bottle, and then smell what's on the stick. And if what's on the stick doesn't smell good, there's a good chance that there's something wrong inside the transmission. And then the last one, if it comes out and that fluid is black or very dark, or even if you see that it's got particles floating in it, that's not good at all. You can take your dipstick and put a little bit of it on a piece of white paper, and you'll see the fluid soak into the paper. And if there's any particles, any black particles located on the surface, that's not good for that transmission. It's time to give it some major repairs, either replacement, overhaul. But it's also part of the diagnosis, so you note that as you continue to try and figure out what exactly is wrong with it. So you don't take the transmission apart and scatter it on a table and then say to yourself, what's wrong with it? So question 2, an electronically controlled automatic transmission is not shifting correctly, and all the following could be performed to locate the cause, except. Now on this one, it's going to give you a list of possible tests that you can perform at some point in diagnosis. And for the most part, D is the absolute correct answer. But when you're in the manufacturer setting at a dealership, there are times when diagnosis might involve reflashing the computer. And we'll get to reflashing in a minute. So during diagnosis, you locate the concern, and in diagnosis, you'll be able to check the fluid level, scan tool data, and diagnose trouble codes. I realize I'm covering up some of this, but you can read it in the PDF that I released. So retrieving DTC is always helpful. You don't want to make a habit of, this transmission is toast, I'm going to pull it out real quick and disassemble it, because what if there was an electrical or electronic concern that caused that clutch or band to fail and you didn't make note of it? So you go to remove the transmission, you disconnect the battery, and there go your DTCs. So pull DTCs even if you know that transmission's coming out, because it might have a code that will prevent failure in the future. So you want to make sure you do that. The other thing is that some manufacturers not only have memory DTCs, but they have on-demand testing DTCs. That means you, in the scan tool, force the engine control or the transmission control module to run a series of tests on itself in the service bay. And that'll give you tests that are considered hard faults, meaning they are failing right now. And those are very helpful too. On the scan tool data, you're going to be able to watch gear ratios, what gear is commanded, what gear is obtained, torque converter clutch operation, electronic pressure control, solenoid operation, all those things there. And you'll be looking for any abnormal signs that will hopefully help in the diagnosis. Let's see, is anything else there? All right, so on to number 3. Proper operation of electronically controlled automatic transmission transaxle depends on proper charging voltage. Proper charging voltage should be, now the ranges they gave you, they said 5 volts. Well, not many vehicles can work on 5 volts, so that's obviously not right. 10 to 12 volts and 13 to 15 volts. And I know some of you are going to be split out there. Well, what if they mean 10 to 12? Or what if they mean 13 to 15? You've got to think about the extremes of those numbers, okay? Okay, the extremes of 10 to 12. 10 volts. Will a vehicle operate properly on 10 volts? No. Will it operate properly on 12? Yes, it will. So 10 to 12, because one end is good, the other end is still bad. Now, the 13 to 15 volts, 13 volts is about charging voltage for most of the time, although some vehicles can get up to 15 volts. They need to be able to absorb that extra voltage, and by doing that, it should be able to operate at 15 volts. So 10 to 12 is a possible answer, but no, it's not, because 10 volts is too low. 13 to 15 volts, man, 15 seems high, but the transmission will still operate. All right, so if it's below specifications, another thing to think about, and it's not just system-wide, but let's say whatever fuse or relay supplies voltage to the transmission operation has excessive resistance in the contacts, So all the solenoids that are getting power from that one relay or fuse are going to be affected in their operation. So what I'm trying to say in this lower section is that if you retrieve DTCs and instead of getting 1 or 2, you get 10 or 11 or 12 or 13 DTCs, and they're all related to shift solenoid 1, 2, 3, 4, all the shift solenoids and the transmission control solenoid and the EPC solenoid. There's more than likely the problem is not with the solenoids, because we have to look at these things as what is most likely going to happen. Are we going to have one relay fail or one fuse fail, or are we going to have 3, 4, 5, 6, or 7 solenoids fail? That is not very likely. So we're going to look and see what they have in common to do our diagnosis, and then we follow through with that. Just remember that these vehicles are not very smart, and it's not that their failures are geniuses. They're just good at hiding, and we just have to be able to find them. All right, so a TV cable breaks. Technician A says that the shift may be too harsh. Technician B says that the shift may occur at too low of a speed or shifts too early. So on this one, they're saying that both are correct. Now, a throttle cable breaking, to me, would seem like that throttle would be low pressure. Well, let's step back and talk about TV. TV stands for throttle valve. And remember, we had spoken about the throttle valve is the hydraulically controlled transmission's load signal from the engine. So it tells the transmission, okay, when to shift and how to shift. So if you're driving with a very light throttle, let's say we have 10, 15% throttle on the gas pedal, as we're driving, that transmission doesn't need to shift harsh. It doesn't need to shift fast. Going from first to second, like really hard and fast. It can take its time during the shift, but it will shorten the shift schedule. First to second shift will happen probably at 8 to 10 miles an hour. And, second and third might happen, 15 to 20 miles an hour. On the other hand, if that throttle pressure were high, let's say we go to wide open throttle, the throttle pressure goes up. And the shift timing will take longer. So instead of happening at 8 to 10 miles an hour for a first to second shift, it will now be at 20 miles an hour because we want to accelerate, keeping the engine in the power band all the way up to 22, 23 miles an hour. It'll shift to second. And then the same thing for third. It might wait all the way until the 40 mile per hour range before it shifts to the next gear. So you can affect shift scheduling and you can affect shift feel, because under wide open throttle, the shift itself will happen very quickly and be a very firm shift. So that is a throttle valve. So technician B says the shift may occur at too low of a speed. Let me double check something here. Yeah, okay. So on the other part, it's saying that the throttle valve, the throttle cable is broken, and what they're trying to refer to is that some manufacturers have engineered into the system a fail-safe. And that fail-safe is if the throttle pressure goes to minimum all the time, there's actually a valve that will tell it to bump up throttle pressure. And in doing so, it will extend the shift schedule, and it will also make for a harsher shift even during normal driving, because the transmission at that point does not have a load signal. So it's going to assume high load, hard shifting. Technician B says that it may occur at too low of a speed. Well, if that transmission doesn't have a fail-safe like the previous comment, then the valve body is going to assume that you have very little throttle input. So you're going to be giving it just maybe 5 or 10%, or in this case, it would say 0% throttle. So when you're accelerating, it thinks, okay, we're just cruising along, doing very little load at all. So it's going to go from first to second at the 5 to 10 mile an hour range, even though you might have the gas pedal floored. So here we have a couple pictures. On the side of this is actually out of a GM. It's an older vehicle. Notice it's a throttle body. And it's got 2 injectors located up in here, and it's on top of the intake manifold. So we have our injectors here, and then there's another one up over here. The fuel line's coming in the back. But what we're worried about is the throttle cable, which is the TV cable, the TV cable, which is this cable right here. And notice it goes up to the throttle shaft on the throttle body. That cable runs all the way down to the transmission and actually goes inside the transmission, okay? And that's TV. It's a mechanical linkage from the carburetor or throttle body all the way down to the transmission to tell the transmission what the load the vehicle is under. Now over here on the right side, this is another method of getting load. And they'll usually use these together. If it has a vacuum modulator, it will usually have a TV cable. But there's many transmissions out there that work with just a TV cable and no vacuum modulator. So the vacuum modulator has engine vacuum that comes from the intake manifold. Let me step ahead. Yeah, that's right there. We'll talk about that in a second. So vacuum actually gets sent in here. Try and write vacuum or just vac. How about that? Wait, hold on. There we go. Close enough. So our vacuum is applied to this nipple. And notice this vacuum modulator diaphragm is mounted, and this thing right here is the case of the transmission. So it's actually sticking from the outside to the inside, and there's a little pin that connects to our modulator valve. And that modulator valve then helps to create either a boost pressure, or it could help to create that load signal inside the valve body. So again, modulator pressure, mod pressure equals modulator pressure, and it's an actual engine load signal used by the transmission valve body to determine shift timing. It is different from TV pressure because TV is a way of determining load, but it's not necessarily that, because you could be at half throttle and be under a lot of load because of how much weight the vehicle's pulling. So a TV cable is kind of like a dumbed down version of engine load. It's more customer or driver demand than it is engine load. All right, so some transmissions will utilize a TV valve only to determine the engine load, and then some of them will use both. If they use both, the TV cable tends to turn into a new thing, which is called a kickdown cable, which will work really similar to that, okay? So remember we had spoken about how automatic transmission shifted without any electronics, and we had the governor. So we have our TV, a modulator pressure, and then our governor assembly. This guy right here, they have it cut away, so this has actually been sawn away. They've reinstalled the governor, and it actually spins right along this shaft. What's sticking out of this hole, because we're kind of below and looking up at it, the output shaft comes out of that hole, and the output shaft has a gear machined into it and then operates against this helical gear here. So as the transmission's output shaft spins, the governor spins. And the faster the governor spins, the higher the governor pressure. So that's how governors operate. Now there are some governors like this one that is mounted adjacent to the output shaft, but then there are some where the governors are mounted to the output shaft. So there's different types, but it just depends whether or not you're going to see one. So shifting without electronics using governor and throttle pressure. So here on the left side, we notice this is before the upshift, okay? So this is before upshift. And what we're looking at is the valve that extends from there to there. So we're looking at this valve right here in the middle. In its downward position, we're in first gear. To get this transmission to shift into second gear, governor pressure has to raise high enough. And notice our governor pressure is coming in from the bottom here, and it goes in there, and it's actually going to pressurize this section here. When that pressure gets high enough, now it's fighting something. It's fighting not only the spring that's inside here, but it's fighting throttle pressure. So if you have very little throttle pressure and you're accelerating, going faster and faster and faster, then the governor pressure will get high enough, and notice that this valve has shifted up. Okay? When it shifts up, it compresses the spring. And we've got to shift all without electronics. And all these other legs here, we can worry about those, but we have throttle pressure and governor pressure, and this is moving our 1-2 shift valve. Now on the other end of it, we could reverse this to make that valve go back down so we can go from second gear to first gear. The throttle pressure, this guy right here, it will go up high enough. So you're cruising at 20 miles an hour in second gear, and you want to get to the downshift, you floor the gas pedal. So you can either affect it with TV cable, TV pressure, or modulator pressure, because it's going to see it go to zero vacuum, which is going to cause the throttle pressure to go up. And that throttle pressure increasing will then, along with this spring, push this valve back down, forcing a 2-1 downshift. And that's how the transmissions are going to shift without electronics. So, last question for this section, which is going to be question 5. Technician A says that the cooler should always be flushed when replacing an automatic transmission or transaxle. Technician B says that aqueous solvent should be used to flush the cooler. Now, what does aqueous mean? Well, that means it's something that is water-based. So that solvent is going to be containing water. So I need to keep that in mind. Technician A is definitely more correct in this question. If you were to replace, rebuild, or perform a major repair on a transmission, you must be sure that none of the old debris gets into the new transmission, because it could cause it to fail. However, of course, that should say flushing the transmission coolers can be difficult, and I've got some pictures in a video for that. Flushing coolers can be very difficult to do properly, and in most cases, such heavily contaminated coolers really should be replaced, even if it's in the radiator. So now, that's Technician A. Yes, he's correct, or she's correct, and it's best to flush it. It's even better to replace it. So let's step on to Technician B. Technician B says aqueous solvents. Now, if you remember, the clutch material on the bands and on the clutch plates and inside the torque converter, they can't use a regular a glue that's going to be broken down by, say, brake clean or oils, because the transmission fluid is an oil and it can break it down. It's going to be a hydrocarbon-based glue. So they need something that won't break down in that, so it's going to be a water-based glue. And that adhesive that's holding all those clutch materials on, if you use an aqueous solvent, if there's some left over in the cooler when you're done, that stuff could get into the transmission and could cause the clutch materials to start ungluing and releasing into the transmission, causing clutch slippage, band slippage, all sorts of things. And it's hard to get all of it out because there's so many cavities inside transmission coolers. Also, the other thing that you could do is that if you can only just flush it, or even if you flush it and let's say it's got a large length of cooler lines, what you can do is install on the return side a filter kit. Okay. Now, this is why we don't. Well, we would prefer to replace the cooler as opposing to just flushing it. So this transmission cooler, it is what's called a double wall tube. It has a tube on the inside and then the tube on the outside. These two tubes are sealed together. So what flows between them is ATF, and that ATF flows from one end of the tube to the other end of the tube. And inside that tube, you kind of see something there, and you actually see it right here. It's a very thick mesh, a brass mesh. And what it does is the fluid has to flow through that mesh. As it flows through the mesh, all of its surface area is accepting the heat from the fluid. On top of that is that mesh is actually compressed inside there, and it's pushing on the inner wall and the outer wall. Now remember, all this tube is submerged inside the coolant in the radiator. So this is on the bottom tank of a radiator, and this thing is just full of this mesh, full of fluid. It's flowing through it. So you could imagine what could be caught by this mesh would be all the small debris. Now, how would you get it out? That's where the problem lies when it comes to flushing coolers. If you can replace it, replace it. If you can flush it, you better flush it well and then put a filter on it. So this right here is showing a filter kit. This is one made by another company for Ford. This is actually a magnetic filtering element. So not only will this one stop particles that are non-ferrous, such as clutch material, bearing material, like plastic bearing material or aluminum, it'll actually stop small pieces of metal that may or may not get through a filter element. So you're going to install this on the return line back to the transmission. So the fluid leaves the transmission in the cooler, goes through the coolers, and then it's heading back to the transmission. That's where you want to install this cooler line filter. Now, once you do this, it becomes a serviceable component. So during a transmission service, if you raise up a vehicle and it's got one of these filters on it, that's part of service. Okay, you replace the fluid, you replace the filter if they want you to, and you also service that filter and put in a new one. It's part of service once you do that. And it depends on the manufacturer. Some of them will say 30,000 miles, that filter needs to be replaced. Okay. Now, in my experience, they are bypass filters, meaning once they get blocked up enough, they'll just open and then not filter as well anymore. They're never going to stop the flow.